Hi, I'm Shashank Shukla, creator and designer of ScaL, and this is ScaL, copyrighted to me, Shashank Shukla. ScaL is just not a calculator, it's an algebra system, graphing software, and numerical analysis software. This demo is obviously about ScaL, and it will show what ScaL can do. On a brief note, ScaL can do normal mathematical functions, sine, cos, tan, matrix manipulation, Fourier transform, interpolation, can solve ordinary differential equations. ScaL can do a lot more things than what that can be covered in this demo. Can handle symbolic mathematics. So let's start. In ScaL, we can do operations on matrix. First clear it. Let's create a matrix, 3 by 3 matrix. That's one way of creating it. First row separated by colon, second row elements separated by colon, and elements are separated by space. So A is essentially a 3 by 3 matrix. What we can do with A is Hamilton transpose, inverse, transpose. Let's start with it, and can do a lot of more things. So let's not go there. Hamilton transpose, also known as conjugate transpose. Inverse, it is inverse of A, and transpose. Let's see how transpose of A looks like. It's transpose matrix. Now, as many of you might be knowing, with matrices we can solve linear equations. So if we have some linear equation that looks like this, it will essentially have, it can be represented by two matrices. It is A and B. A matrix this first column represents x variables, y, z, and solution would be inverse of A into B. So these are the values of x, y, and z respectively. When we solve this equation, we will get value of x, y, and z this manner. Apart from this, we can solve it with linear algebra. Their solution with linear algebra. You can also calculate determinant of a matrix. So here is the determinant, minus 25, that matrix. And again, we can calculate eigenvalues. These are the eigenvalues. We can resize ScaL. Okay, so here we can scroll up, scroll down, resize. These are the eigenvalues: 3 first, separated by space, second and third. Then we can also calculate eigenvalues, eigenvectors pairs. So this is eigenvalue, eigenvector pairs. What more we can do is access by index, it is first. This gives us eigenvalues identical to eigenvalues calculated before, and eigenvectors corresponding to each eigenvalue. These are the eigenvectors. So let's display first eigenvector. First eigenvector. This, the very first eigenvector, this one, that's U. Now we can also do LU composition, find out LU composition of a matrix. LU decomposition is a matter of fact. Here's the decomposition. Let's clear these results. Now this is second way how we can create matrix. We can either use variables or can provide values directly. For now, for the sake of clarity, I will use using variables. So previously rows separated by comma. Now we are using another method of creating matrix by square brackets. Innermost represent row, outer column. We have a matrix, something like this. That's A. And what we can do with complex matrix, apart from regular thing, that is Hamilton transpose, LU composition, determinant, we can also find out conjugate. So here is the conjugate matrix.